Welcome to Milky Narratives. Tonight, set aside the noise of the day, breathe deeply, and let your thoughts drift gently among the stars. Together, we'll explore the quiet mysteries that lie beyond the edge of the known universe. 1. Some worlds refused to die. Most planets are born alongside their stars. They emerge from the same swirling cloud of gas and dust. They spend billions of years circling their parent sun, sharing its fate, growing beneath its light, and depending on its warmth. At least, that is how the story is supposed to go. But tonight, we are going to explore something far stranger. Because scattered throughout our galaxy are worlds that should not still exist. Worlds that survived disasters so immense that astronomers once believed nothing could possibly endure them. Worlds that watched their suns expand into giant monsters. Worlds that endured infernos capable of melting entire planetary systems. Worlds that somehow remained after explosions powerful enough to outshine entire galaxies. And perhaps most astonishing of all, some of these survivors are still there today, still orbiting, still enduring, still carrying silent records of catastrophes that happened billions of years ago. When we look at the night sky, we often imagine planets as fragile places, tiny islands of rock and ice suspended in a vast and dangerous universe. That assumption feels reasonable. After all, planets seem small compared with stars. A star can be hundreds, thousands, or even millions of times larger than the worlds that orbit it. The balance appears obvious. The star is powerful, the planet is vulnerable. Yet the universe has a habit of surprising us. Because sometimes the seemingly fragile object survives, while the giant that created it is transformed beyond recognition. Imagine standing on a distant world, long after its star has begun to die. For billions of years, the sun above has looked stable and eternal. Then slowly, almost imperceptibly, everything begins to change. Deep within the star, hydrogen fuel starts running low. The delicate balance between gravity and pressure begins to shift. The star swells, its outer layers expand farther and farther into space. The sky grows brighter, the temperatures rise. Oceans evaporate, atmospheres are stripped away. Entire planetary environments begin to collapse. For worlds orbiting close to the star, there may be no escape. Some will be consumed completely. Others will be torn apart. Still others may be reduced to glowing remnants drifting through expanding clouds of stellar debris. For a long time, astronomers assumed this was the inevitable fate of most planetary systems. The death of the star would mean the death of the worlds around it. But reality turned out to be far more complicated. As telescopes became more powerful, scientists began discovering something unexpected. Planets around dead stars, not hypothetical planets, not possible planets, actual planets, real worlds orbiting stellar corpses. Some circle white dwarfs, the dense remnants left behind after stars like our sun shed their outer layers. Others may orbit neutron stars, objects so extreme that a teaspoon of their material would weigh billions of tons. The existence of such worlds raises an extraordinary question. How did they survive? How could a planet endure an event capable of completely transforming a star? The answer appears to be different in every case. Some planets may have formed farther away from the violence and simply remained beyond the most destructive regions. Others may have migrated outward as their dying stars lost mass. Some may have been reshaped, scorched, and partially destroyed, yet somehow remained intact. And there is an even stranger possibility. A few worlds may not be survivors at all. They may be reborn. In certain systems, the debris left behind by a dying star could potentially gather together again. New worlds might emerge from the ashes of old ones. Entire planets forming after the catastrophe rather than before it. The distinction is remarkable. Did the world survive the disaster, or was it created because of the disaster? Sometimes astronomers are still trying to find out. This uncertainty is one reason these systems are so fascinating. They force us to rethink what planetary death actually means. In human experience, destruction usually feels final. A building collapses, a forest burns, a civilization disappears. We instinctively imagine clear endings. The universe often prefers transformations instead. A dying star does not simply vanish, it changes. And the worlds around it may change as well. Some disappear, some survive, some evolve into something entirely new. The story continues long after the chapter we expected to be the ending. That realization makes the cosmos feel strangely alive. The night sky is not merely a collection of objects frozen in place. It is a landscape of ongoing survival, of adaptation, of endurance, of worlds struggling through events almost beyond imagination. And perhaps that is what makes these planetary survivors so captivating. They are not simply astronomical curiosities. They are reminders that cosmic history is rarely straightforward. A planet can lose its oceans and still remain. A world can witness the death of its sun and continue orbiting for billions of years afterward. A seemingly ordinary point of light can conceal a history of fire, destruction, and improbable survival. Some worlds refused to die. And as we continue our journey tonight, we will discover that their stories are far stranger than anyone once believed. 2. Rogue planets wander through eternal night. There is a strange assumption hidden inside almost every picture we carry of a planet. A planet belongs to a star. Earth belongs to the sun. Mars belongs to the sun. Jupiter belongs to the sun. Even when we discover worlds around distant stars, we still imagine the same arrangement repeating across the galaxy. A bright star in the center, planets circling faithfully around it like dancers around a fire. But the universe is under no obligation to follow our expectations. Because scattered throughout the Milky Way may be countless worlds that belong to no star at all. No sunrise, no sunset, no warm light crossing an atmosphere. No golden star hanging in the sky, only darkness, endless darkness. These are the rogue planets, worlds that drift alone through interstellar space, planets that have been cast out of their homes and condemned to wander the galaxy forever. And what makes them fascinating is not simply that they exist, it is the unsettling possibility that there may be more rogue planets than there are stars. Imagine that for a moment. The night sky above Earth is filled with thousands of visible stars. Our galaxy contains hundreds of billions more. Yet hidden between them may be an even larger population of invisible worlds moving silently through the dark. Entire planets, entire landscapes, entire histories, floating unseen between the stars. For most of human history, we had no reason to suspect such objects existed. A planet without a star sounds almost contradictory. After all, stars are usually the architects of planetary systems. They form first, the planets emerge later from the leftover material orbiting them. Everything seems connected, everything appears stable. Yet when astronomers began studying planetary systems beyond our own, a surprising realization emerged. Planetary systems can be chaotic places, especially during their youth. Newborn systems often contain multiple giant planets interacting gravitationally with one another. Each world pulls on the others, orbits shift, resonances form, instabilities grow, and sometimes the cosmic balancing act fails completely. When that happens, one unlucky planet may receive a gravitational shove powerful enough to escape its star forever. A single close encounter can be enough. One giant planet swings past another, energy is exchanged. One settles into a safer orbit, the other is flung outward, farther, farther, farther still, until eventually the star's gravitational grip breaks. The planet is gone, not destroyed, not shattered, simply exiled, a world sentenced to eternal night. The process sounds violent, yet from the planet's perspective, the transition might happen gradually. The parent star would slowly shrink in the sky. The warmth would fade. The oceans, if they existed, might begin freezing. The atmosphere could collapse. The entire environment would change as the world drifted farther from the source of nearly all available energy. Eventually, the star would become just another bright point among countless others, its former home lost within the vastness of the galaxy. And then the true journey would begin. Because once a rogue planet enters interstellar space, it encounters a universe unlike anything we experience on Earth. The darkness there is difficult to imagine. Even the coldest winter night on our planet remains flooded with energy compared to interstellar space. Earth constantly receives sunlight. The atmosphere stores heat. The oceans transport energy around the globe. Life benefits from a remarkable abundance of warmth. A rogue planet receives none of that. Its surroundings may fall toward temperatures only a few degrees above absolute zero. The darkness becomes nearly complete. No sunrise ever breaks the horizon. No daylight returns. Only the distant glow of stars scattered across the sky. And yet, that might not mean such worlds are completely dead. Because planets possess something stars do not always control: internal heat. Deep beneath Earth's surface lies an enormous reservoir of energy, left over from planetary formation and radioactive decay. Even today, billions of years after Earth's birth, our interior remains hot enough to drive volcanoes, earthquakes, and continental motion. A rogue planet could retain similar heat. In fact, if the planet were sufficiently massive and insulated beneath thick layers of ice, something extraordinary might happen. An underground ocean could survive. Picture an ocean hidden beneath kilometers of frozen crust. Above it, endless darkness. Below it, liquid water. No sunlight, no blue skies, no seasons. Yet perhaps an environment stable enough to persist for billions of years. Scientists have explored this possibility seriously because we already see hints of similar environments within our own solar system. Moons such as Europa and Enceladus may contain hidden oceans beneath thick ice shells. These oceans survive because internal energy keeps them from freezing solid. If that can happen around giant planets, perhaps something similar could happen on rogue worlds wandering through interstellar space. Suddenly, the question becomes more unsettling. Could life survive there? Not life like forests or birds or oceans beneath sunlight. Something stranger, something adapted to permanent darkness. On Earth, entire ecosystems thrive around deep-sea hydrothermal vents where sunlight never reaches. These organisms rely on chemical energy instead of photosynthesis. Life found another path. And if nature discovered that path once, could it discover it elsewhere? No one knows. But rogue planets force astronomers to consider possibilities that once seemed absurd. A world without a star, an ocean without sunlight, potential habitats drifting through the void between stellar systems. The galaxy may contain environments more diverse than we ever imagined. What makes rogue planets especially haunting is their loneliness. Most worlds exist within families. They orbit stars. They share skies with neighboring planets. They experience gravitational relationships that shape their destinies. Rogue planets have none of that. A rogue world may travel for millions or even billions of years without coming close to another star. The distances are immense. The encounters are rare. Most of the time, nothing happens. The planet simply drifts, silent, cold, invisible, crossing the galaxy at tens of kilometers per second, passing through giant molecular clouds, moving between spiral arms, witnessing cosmic history without ever belonging to any system again. In a strange way, rogue planets challenge our definition of what a planetary life should look like. We tend to imagine planets as supporting characters in a stellar story. The star is the protagonist, the planets merely orbit around it. But rogue worlds reveal that planets can have stories of their own. They can survive expulsion. They can endure isolation. They can persist long after losing the central object that once defined their existence. Perhaps some have wandered for billions of years, longer than Earth has existed, longer than entire ecosystems have risen and vanished on our planet, longer than humanity could easily comprehend. Still traveling, still carrying the scars of events that occurred near stars now impossibly distant. And somewhere out there, hidden in the darkness between the visible lights of the Milky Way, countless such worlds may already be drifting. Unseen, unlit, almost impossible to detect. Ancient survivors of forgotten planetary systems. Worlds without sunrises, worlds without sunsets. Worlds whose skies have known only eternal night. And yet, despite all that darkness, they remind us of something profound. A planet does not necessarily cease to exist when it loses its star. Sometimes it simply begins a different journey, one far colder, far lonelier, and far stranger than anything we once imagined possible. 3. Failed stars that almost became suns. Some objects in the universe spend their entire existence standing on the edge of becoming something greater. Not planets, not stars, something caught in between. a strange category of cosmic bodies born from the same clouds that create stars, yet forever denied the fire that makes a true sun shine. Astronomers call them brown dwarfs, but that name hardly captures how extraordinary they really are. Because brown dwarfs are failed stars, objects that came heartbreakingly close to becoming suns, and missed. Imagine witnessing the birth of a star. Deep inside a vast molecular cloud, gravity slowly gathers gas and dust together. The growing mass becomes denser, hotter, more compressed. The pressure increases relentlessly. For millions of years, gravity pushes inward while temperature rises ever higher. Eventually, if enough material accumulates, something remarkable happens. Hydrogen nuclei begin fusing. A true star is born. Light floods outward. A new sun ignites. This process has repeated countless trillions of times across cosmic history. Yet not every collapsing cloud succeeds. Sometimes gravity gathers a large amount of material, enough to create something much larger than a planet, enough to generate enormous heat, enough to resemble a star in almost every visible way, but not quite enough. The object falls short of the critical mass needed to sustain hydrogen fusion, and at that moment, its fate changes forever. It will never become a true star. It will spend billions of years cooling slowly in darkness. Neither planet nor sun, a permanent cosmic in-between. That sounds almost tragic, yet brown dwarfs may be among the most fascinating objects in the galaxy because they reveal something profound about how nature works. The universe does not always create neat categories. Reality often produces continuums, gradients, borderlands. Brown dwarfs live inside one of those borderlands. If a planet is one side of the frontier and a star is the other, brown dwarfs occupy the mysterious territory in between. Many are dozens of times more massive than Jupiter. Some contain enough mass to briefly fuse deuterium, a heavier form of hydrogen. Others glow faintly with residual heat from their formation. For a time, they can appear surprisingly star-like, yet the crucial threshold remains out of reach. They never achieve the stable hydrogen fusion that powers true stars. They almost became suns. Almost. And in astronomy, sometimes almost creates entirely new worlds of possibility. What makes brown dwarfs especially strange is that they do not simply switch off after failing. When they first form, they can be remarkably hot. Some glow deep red, others radiate strongly in infrared light. To nearby observers, they might initially appear similar to small stars. But unlike stars, they possess no long-term energy source. They are living off stored heat, like cosmic embers cooling after a fire that never fully ignited. Over time, they fade. Slowly, patiently, relentlessly. Millions of years pass, then billions. The glow weakens, the temperature falls. The object grows darker and darker. A true star becomes brighter during its long life. A brown dwarf spends its existence becoming dimmer. It is a completely different story. One of the strangest consequences of this existence is that age becomes difficult to judge. Young brown dwarfs can appear surprisingly bright. Ancient ones can become extraordinarily faint. Two objects with similar masses may look dramatically different simply because one has been cooling longer. In a sense, brown dwarfs carry clocks inside themselves. Their fading light records the passage of cosmic time, and astronomers have learned to read those clocks. By studying their temperatures, brightness, and spectra, scientists can estimate how long these failed stars have been drifting through the galaxy. Some have existed for billions of years. They were already old when Earth formed, already cooling when the first oceans appeared, already fading when dinosaurs walked beneath the sky. Their quiet decline stretches across almost unimaginable spans of time. Yet despite being difficult to see, brown dwarfs are everywhere. In fact, astronomers suspect our galaxy contains enormous numbers of them. Many remain undiscovered because they emit so little visible light. Finding them often requires infrared telescopes capable of detecting faint heat signatures invisible to human eyes. When those instruments scan the darkness, hidden populations begin to emerge. Suddenly, regions of space that appeared nearly empty reveal countless dim objects lurking between the stars. The Milky Way may be crowded with failed suns. silent, cold, almost invisible, and yet very real. Some brown dwarfs possess weather, not ordinary weather like Earth's, something far stranger. Imagine clouds made not of water droplets, but of molten minerals, vaporized metals, hot silicates, entire atmospheric systems composed of substances that would be solid rock on our planet. Powerful winds may race across these alien skies, storms larger than worlds, cloud layers forming and dissipating over time. Lightning may flash through exotic atmospheres unlike anything found within our solar system. Incredibly, astronomers have detected evidence suggesting that some brown dwarfs experience changing weather patterns. Even though they are failed stars, they can possess dynamic, evolving atmospheres. The result is a remarkable paradox. A body too small to become a sun can still host weather more exotic than many planets. Nature refuses to make simple distinctions. The deeper we look, the stranger the categories become. Brown dwarfs have also challenged astronomers' understanding of planetary systems. Some drift alone through space, others orbit stars. Some even appear to host planetary companions of their own. This creates an intriguing question. If a planet can orbit a brown dwarf, and a brown dwarf occupies the boundary between stars and planets, where exactly should we draw the line? The answer is not always obvious. And perhaps that uncertainty is part of what makes these objects so captivating. They remind us that the universe rarely conforms to the tidy labels humans prefer. Reality is often messier, more gradual, more nuanced. Brown dwarfs are not mistakes. They are outcomes, natural products of the same processes that create stars. The cosmos did not fail when it made them. It simply explored another possibility. That idea becomes even more beautiful when viewed from a larger perspective. We often imagine success and failure as opposites. A star ignites, a brown dwarf does not. One succeeds, one fails. But the universe does not think that way. The brown dwarf still exists, still evolves, still shapes its surroundings, still carries secrets about gravity, atmospheres, and planetary formation. Its story is different, not meaningless. In fact, some of the most important discoveries in astronomy have emerged from studying objects that refuse to fit neatly into established categories. The exceptions often teach us more than the rules, and few objects embody that lesson better than failed stars. Perhaps that is why brown dwarfs feel strangely compelling. They exist on the threshold, balanced forever between two identities, too massive to be planets, too small to become suns, wandering the galaxy as permanent reminders that nature rarely deals in absolutes. Somewhere tonight, hidden among the countless lights of the Milky Way, ancient brown dwarfs continue their silent journeys, cooling, fading, drifting through the darkness. Worlds that nearly became stars, objects that came astonishingly close to igniting, yet never crossed the final line. And somehow, because of that, they became something even more intriguing. If you're enjoying tonight's journey through the universe, take a moment to subscribe and join us for more explorations of the strangest and most fascinating mysteries hidden among the stars. 4. Worlds that orbit dead stars. What happens to a planet when its star dies? At first, the question sounds simple. Stars are born, stars live, stars die. And planets, we naturally assume, either die with them or drift away into darkness. The story seems straightforward, but the universe rarely settles for straightforward answers. Because scattered throughout the galaxy are worlds that continue orbiting stars long after those stars should have ceased to exist. Worlds circling stellar corpses. Worlds illuminated not by living suns, but by the fading remains of stars that completed their life cycles billions of years ago. And some of those planets may be among the strangest places in the entire universe. To understand them, we first need to imagine the future of our own solar system. Right now, the sun appears stable, comforting, reliable. Every sunrise feels ordinary because it has happened every day of our lives. Yet beneath that familiarity, an unstoppable clock is ticking. The sun is slowly converting hydrogen into helium deep within its core. Every second, millions of tons of matter become energy. The process is astonishingly efficient, but it cannot continue forever. One day, billions of years from now, the sun's hydrogen supply will begin to run low. And when that happens, everything changes. The core contracts, temperatures rise, the outer layers expand. The sun transforms into a red giant, a swollen star so enormous that its outer atmosphere may reach the present orbit of Earth. Mercury will almost certainly disappear. Venus will almost certainly disappear. Earth's fate remains uncertain, but survival would be extraordinarily difficult. The inner solar system will become a place of fire. Oceans will vanish, atmospheres will be stripped away, entire worlds will be sterilized. For a brief period, the dying sun will become more dangerous than it was during its entire stable lifetime. And yet, this is not the end of the story. Eventually, the outer layers drift away into space. A beautiful planetary nebula forms. The remaining core is exposed. The giant star dies. What remains is a white dwarf, a stellar remnant roughly the size of Earth. Incredibly dense, extraordinarily hot, yet no longer powered by fusion. A dead star. And this is where things become fascinating, because the white dwarf does not vanish. It continues to exist for billions of years, perhaps trillions, slowly cooling, slowly fading, still exerting gravity, still capable of holding planets in orbit. The star is dead, but the system itself may survive. Imagine standing on a world orbiting such an object. The sky would be unlike anything humans have ever experienced. A white dwarf contains roughly the mass of the sun compressed into a volume similar to Earth. As a result, it can appear brilliant despite its tiny size. Instead of seeing a vast solar disk dominating the heavens, you might see a compact white jewel suspended in darkness. Small, intense, almost unnaturally bright. A dead star masquerading as a living sun. The realization would be difficult to escape. Every sunrise would come from a stellar corpse. Every shadow would be cast by something that once died. Yet some planets genuinely do orbit white dwarfs. Astronomers have found evidence suggesting that planetary systems can survive stellar death far more often than previously imagined. Not always intact, not always unchanged, but not necessarily destroyed. When a star loses mass during its giant phase, planetary orbits can expand. Worlds migrate outward. Gravitational relationships shift. Entire systems reorganize themselves. Some planets are lost. Others survive. A few may even move into new configurations that become stable for billions of years afterward. The death of the star becomes not an ending, but a transformation, a cosmic reshuffling. And occasionally, the survivors remain. What makes this possibility so intriguing is that it forces us to rethink the meaning of habitability. We often assume life requires a stable main sequence star like the sun. That assumption makes sense. Every known ecosystem on Earth ultimately depends on sunlight. But white dwarfs remain hot for extraordinarily long periods. A planet orbiting at the correct distance could theoretically receive suitable amounts of energy. Not forever, but potentially for billions of years. Some scientists have even wondered whether life could emerge or survive around such stars. The idea sounds exotic, yet nature has surprised us before. Again and again, the universe reveals environments that once seemed impossible. Perhaps dead stars should not be dismissed too quickly. In fact, some of the most dramatic evidence for planetary survival comes from something unexpected. Pollution. Not atmospheric pollution, stellar pollution. Astronomers studying certain white dwarfs noticed unusual chemical signatures within their spectra. Heavy elements, calcium, iron, magnesium, materials that should have disappeared beneath the star's surface long ago. Something was continually replenishing them. The mystery eventually pointed toward a remarkable conclusion. The white dwarfs were consuming planetary debris, asteroids, fragments of destroyed worlds, the remains of ancient planetary systems. Long after stellar death, the gravitational machinery continued operating. Objects still collided, still migrated, still fell inward. The dead star continued feeding on the ruins of its former family, like an archaeological record preserved in starlight. By studying these chemical traces, astronomers can reconstruct the composition of worlds that no longer exist. Entire planets leave fingerprints inside the stars that destroyed them. It is one of the strangest forms of cosmic forensic science ever developed. And it reveals that planetary systems remain active long after the parent star's death. The story does not simply stop. The drama continues. Some systems become even stranger. There are indications that new planets might occasionally form after a star dies, not from the original protoplanetary disk, but from material left behind during stellar evolution. Imagine that, a second generation of worlds, planets born from the ashes of earlier systems, children of stellar death rather than stellar birth. The evidence remains uncertain, the questions remain open, yet the possibility itself is breathtaking, because it suggests that cosmic endings may sometimes create new beginnings. Perhaps nowhere is this theme more powerful than in the emotional symbolism of white dwarf systems. When we think about death, we often imagine disappearance, finality, an irreversible conclusion. Yet astronomy repeatedly presents a different picture. Stars die, but their gravity remains. Their remnants endure. Their planets sometimes survive. Their material seeds future generations of stars and worlds. The boundary between ending and beginning becomes blurred. A dead star may still illuminate a sky. A destroyed planet may help create another. The universe recycles almost everything. Even death becomes part of a longer story. And somewhere tonight, hidden among the hundreds of billions of stars in the Milky Way, countless ancient white dwarfs continue cooling in silence. Many have been dead longer than complex life has existed on Earth. Many may still possess planetary companions, worlds orbiting forgotten suns, worlds that witnessed stellar catastrophe and endured, worlds whose skies are illuminated by the glowing embers of stars that died billions of years ago. Silent survivors, circling cosmic ghosts. Proof that sometimes the most extraordinary chapters of a planetary story begin only after the star itself has already reached its end. 5. Planets made of diamond and exotic matter. There is a comforting assumption hidden inside everyday life. The world around us feels familiar. Stone is stone, water is water, metal is metal. The atoms that make up mountains, oceans, clouds, and living creatures behave in ways we understand. Even when matter becomes hot, cold, liquid, solid, or gas, it still belongs to a universe that feels recognizable. But travel far enough into the cosmos, and that sense of familiarity begins to dissolve. Because there may be worlds where matter itself takes forms so strange that the boundary between planet and impossibility starts to blur. Planets made partly of diamond. Worlds dominated by exotic carbon chemistry. Objects compressed into states unlike anything naturally found on Earth. Places where the very definition of a planet begins to stretch beyond intuition. And what makes this remarkable is that none of these ideas necessarily belong to science fiction. They emerge from the strange consequences of physics itself. The universe, it turns out, is capable of building worlds from ingredients far more unusual than those found in our solar system. To understand why, imagine the incredible diversity already present among the planets we know. Earth is rocky. Jupiter is mostly hydrogen and helium. Neptune contains enormous quantities of water, methane, and ammonia deep within its interior. Even within our own cosmic neighborhood, planets can differ dramatically. Now imagine multiplying that diversity across hundreds of billions of stars. Suddenly, it becomes difficult to argue that Earth-like worlds should be the norm. Perhaps they are merely one possibility among countless others. Some planetary systems may have formed from clouds unusually rich in carbon. Others may have experienced violent histories that transformed their interiors through crushing pressure and extreme temperatures. The result could be worlds whose chemistry diverges radically from anything familiar. And among the most famous examples are the so-called diamond planets. The phrase sounds almost mythical. A jewel the size of a world, a planet glittering like a gemstone. Reality is somewhat more complicated. Yet in some circumstances, physics genuinely allows enormous quantities of carbon to become compressed into crystalline structures deep inside a planet. Pressure changes everything. On Earth, carbon may appear as graphite, coal, or diamond, depending on conditions. Increase the pressure enough, and atoms rearrange themselves into entirely new forms. Now imagine pressures millions of times greater than those found at Earth's surface. Deep inside massive planets, carbon could potentially crystallize on extraordinary scales. Not small gemstones, entire layers, entire mantles, perhaps entire worlds. One famous candidate often discussed by astronomers is a planet known as 55 Cancri e. Although its exact composition remains debated, studies have suggested that carbon-rich interiors may exist on some exoplanets. If true, such worlds could possess geology unlike anything humans have ever seen. Their mountains, their crusts, their interiors, all shaped by unfamiliar chemistry. The idea itself is captivating. Yet diamond worlds are only the beginning, because exotic matter in astronomy does not simply mean unusual minerals. Sometimes it means matter behaving in ways that challenge common sense. Consider what happens deep inside giant planets. The pressures become so immense that substances we think we understand begin transforming into entirely new states. Hydrogen offers a remarkable example. On Earth, hydrogen is a gas, invisible, light, simple. But inside giant planets, gravity squeezes hydrogen so intensely that electrons become free to move through it. The result is something called metallic hydrogen, a substance that behaves less like a gas and more like an electrically conducting metal. Imagine an ocean made of metallic hydrogen, not water, not liquid metal in the ordinary sense, something stranger. A material that can conduct electricity while existing under pressures beyond human experience. Scientists believe enormous oceans of metallic hydrogen may exist deep inside planets like Jupiter. If such transformations occur within our own solar system, imagine what might happen inside even larger worlds orbiting distant stars. Nature has had billions of years to experiment. The results may be astonishing. Some exoplanets are so massive and so hot that their environments border on the surreal. On certain worlds, temperatures become high enough to vaporize rock. Not melt it, vaporize it. Stone becomes atmosphere, minerals become clouds, silicates drift through alien skies. In these environments, weather itself may operate according to rules completely different from those on Earth. Instead of water clouds, there may be clouds of rock vapor. Instead of rain, molten minerals could condense and fall through the atmosphere. Imagine standing beneath a sky where droplets of liquid stone descend from the clouds. The image feels impossible, yet physics does not forbid it. Under the right conditions, the universe allows such things to happen. And then there are the truly extreme possibilities. Worlds orbiting pulsars, planets surviving near white dwarfs, bodies exposed to intense radiation fields capable of reshaping their chemistry over billions of years. Each environment acts as a laboratory where matter is pushed into unfamiliar regimes. The farther astronomers look, the more they discover that planetary diversity may have almost no obvious limit. What is perhaps most humbling is how little we currently know. For most of human history, we knew only 8 major planets. Today, thousands of exoplanets have been discovered, and every year adds new surprises. Hot Jupiters orbiting perilously close to their stars. Super-Earths larger than any rocky world in our solar system. Mini Neptunes occupying categories we never knew existed. Entire classes of planets absent from our own celestial neighborhood. This suggests something profound. The solar system may not be a standard example. It may be just one local variation. One chapter in a much larger story. And if that is true, then some of the strangest worlds may still be waiting to be found. Planets whose interiors contain materials never before observed naturally. Planets whose atmospheres challenge our understanding of chemistry. Planets built from combinations of pressure, temperature, and composition that have no equivalent around the sun. The galaxy is vast enough to accommodate possibilities we have not yet imagined. That realization becomes even more striking when we remember how planets form. They are not designed. They are not planned. They emerge naturally from gravity, chemistry, and time. No intelligence decides what kind of world should exist. The laws of physics simply operate. Again and again, across billions of star systems, across hundreds of billions of stars, across incomprehensible spans of time. And occasionally those laws produce outcomes so strange that they seem almost artistic. Worlds of crystal, worlds of metallic oceans, worlds where rock behaves like weather, worlds whose very substance stretches the limits of human imagination. Perhaps the most beautiful lesson hidden within these exotic planets is that reality remains larger than our expectations. Every generation assumes it understands the basic possibilities of nature. Then the universe reveals something unexpected, a new phenomenon, a new world, a new configuration of matter. And suddenly the cosmic landscape becomes richer than before. Somewhere tonight, beyond the reach of our telescopes, there may be planets whose composition would seem impossible if we encountered them tomorrow. Worlds forged under pressures beyond comprehension. Worlds built from unfamiliar chemistry. Worlds where the materials beneath your feet would barely resemble anything found on Earth. Silent planets drifting around distant stars. Alien beyond appearance. Alien in substance itself. Proof that even something as familiar as a planet can become extraordinary when the universe is given enough space, enough time, and enough imagination written into the laws of physics. 6. The survivors of stellar catastrophes. Some planets survived the most violent events their stars could unleash. At first, that sounds impossible. A star is not a gentle neighbor. It controls the temperature of entire planetary systems. It floods space with radiation. It shapes atmospheres, oceans, climates, and chemistry. And when a star begins to die, the transformation can become unimaginably destructive. Yet scattered across the galaxy, astronomers have discovered evidence suggesting that some worlds endured catastrophes that should have erased them completely. Tonight, we explore the survivors, the worlds that watched their suns change into monsters. The planets that endured expanding stellar giants, lethal radiation storms, and even stellar explosions. And perhaps most astonishing of all, some of them may still be there, still orbiting, still waiting beneath skies forever changed. Because in the universe, survival is sometimes stranger than destruction itself. When most people imagine the death of a star, they picture a dramatic explosion. But many stars never explode at all. Stars similar to our own sun die more slowly, far more slowly. For billions of years, they spend their lives quietly converting hydrogen into helium deep inside their cores. The process is stable, predictable, comforting, but eventually the hydrogen runs low, and that is when everything changes. The balance between gravity and pressure begins to shift. The core contracts. Temperatures rise. The outer layers swell outward. What was once an ordinary star gradually transforms into a red giant, and red giants can become enormous. Some grow so large that they would engulf the inner planets of their systems entirely. If our sun followed this path today, Mercury would disappear. Venus would almost certainly vanish. Earth's fate remains complicated and uncertain, but the planet would be rendered unrecognizable long before any final outcome. Oceans would boil away, atmospheres would be stripped, surface rock would melt beneath relentless heat. The familiar world we know would cease to exist. For planets orbiting close to their stars, the red giant phase is often a death sentence. Yet not every planet lives nearby. Farther out, some worlds may witness the entire catastrophe from a safer distance. Imagine standing on such a planet. For billions of years, your star appears stable. Then, over millions of years, it begins growing larger, brighter, redder. The star slowly expands until it dominates the sky. The night disappears. Temperatures rise. Frozen moons begin to thaw. Ancient ice worlds become temporary oceans. Regions that were once lifeless suddenly experience warmth for the first time in their history. For a brief cosmic moment, the habitable zone itself migrates outward. Entire worlds may enter climates they were never meant to experience. But the peace never lasts, because the expanding giant continues changing. It sheds mass. Powerful stellar winds stream into space. Vast quantities of gas drift away. And something remarkable happens. As the star loses mass, its gravitational grip weakens. The surviving planets begin drifting outward. Their orbits slowly expand. The worlds become more distant from the dying star. Sometimes that outward migration helps save them. Instead of spiraling into destruction, they retreat from danger, not because they choose to, not because they fight, but because the very act of stellar death reshapes the architecture of the system. The star weakens, the planets move away, and some survive. When astronomers search the galaxy, they find evidence that this process may be surprisingly common. Around certain white dwarfs, the dense stellar remnants left behind after sun-like stars die, scientists have detected clues suggesting that planetary systems endured the transition. White dwarfs are extraordinary objects. Imagine compressing roughly the mass of the sun into a sphere similar in size to Earth. Matter becomes astonishingly dense. A teaspoon would weigh tons. Yet despite that density, a white dwarf is no longer actively generating energy through fusion. It is the cooling ember of a once living star, the surviving heart left behind after the outer layers drift away. For a long time, astronomers wondered whether any planets could remain after such a transformation. The answer increasingly appears to be yes. Some planets likely migrated outward and endured. Others may have been scattered into new orbits. Entire planetary systems could have been rearranged during the chaos. The result is a strange new solar system orbiting a stellar corpse. Imagine a planet circling a white dwarf. The sky would never resemble the one we know. The central object would appear tiny compared to the swollen giant that preceded it. Yet despite its small size, it could still shine intensely. A brilliant white jewel hanging in darkness. The dead core of a vanished sun. And around it, survivors continue their silent journeys. But red giant death is gentle compared to what happens when truly massive stars reach the end. Massive stars live fast. They burn fuel with astonishing intensity. Their lives are shorter, their endings far more violent. Eventually, their cores collapse. The balance supporting the star vanishes. Gravity wins, and the star detonates in one of the most powerful explosions in the universe, a supernova. For a brief period, a single dying star can outshine entire galaxies. Shockwaves race outward, radiation floods space. Matter is hurled into the surrounding darkness at incredible speeds. Surely no nearby planet could survive that. And for many worlds, that is true. Entire planetary systems may be sterilized, atmospheres stripped away, surfaces blasted by radiation. The violence is difficult to comprehend. Yet even here, nature refuses to follow simple rules, because survival depends on distance. A planet close to the explosion faces catastrophe, but one located far enough away may endure. Damaged, transformed, scarred forever, yet still existing. Imagine witnessing a supernova from a distant surviving world. For days, weeks, or months, a new light dominates the sky, brighter than any star, brighter perhaps than a full moon. The heavens themselves seem on fire. Then slowly the brilliance fades. The explosion expands outward, and eventually what remains is something even stranger. A neutron star, or perhaps a black hole. The dead remnant of the star now occupies the center of the system. If the planet survives gravitational disruption, it may continue orbiting this bizarre new object. The same world, but beneath an entirely different sky. Astronomers have actually discovered planets orbiting neutron stars, and their existence remains one of the most astonishing surprises in modern astronomy. Because neutron stars are born from supernovae, which means either those planets somehow survived the explosion, or they formed afterward from material left behind. Both possibilities are extraordinary. Both reveal that planetary systems are far more resilient than we once imagined. And perhaps that is the deepest lesson hidden within these cosmic survivors. We often think of catastrophe as an ending, a final chapter, a point beyond which nothing remains. The universe tells a different story. Again and again, worlds endure events that seem impossible to survive. Stars swell into giants. Planets migrate, stars explode, orbits change, entire systems are rewritten, and yet some planets remain, still circling, still existing, still carrying the memory of disasters written across billions of years. These worlds are not untouched. They are not unchanged. They are survivors, living records of cosmic upheaval. Proof that even among the most violent forces in existence, destruction is rarely the whole story. Sometimes, after the fire has passed, something remains. 7. The strange graveyards around white dwarfs. What happens to a planetary system after its star dies? Most people imagine a clean ending. A star exhausts its fuel. Its light fades. Its planets disappear into darkness. The story is over. But the universe rarely offers endings that simple. In reality, the death of a star often creates something stranger. A vast cosmic graveyard. A place filled with shattered worlds, drifting debris, surviving planets, and the remains of ancient systems that once looked stable and permanent. Tonight, we wander through those graveyards. Not the graveyards of stars themselves, but the graveyards left behind around white dwarfs. The silent cemeteries where entire planetary systems have been broken apart, and where astronomers have discovered some of the most haunting evidence that worlds can continue to exist long after their suns have died. A white dwarf is what remains when a star similar to our sun reaches the end of its life. After billions of years of fusion, the star expands into a red giant. Its outer layers drift away into space. The core survives, compressed, dense, hot, and astonishingly small. A white dwarf contains roughly the mass of a star, packed into a volume comparable to Earth. It no longer produces energy through fusion. It simply radiates the heat left over from its former life, slowly cooling over billions of years. At first glance, such a stellar remnant seems peaceful. The violence is over. The transformation is complete. Yet when astronomers began studying white dwarfs more carefully, they noticed something unexpected. Many of them appeared contaminated. Their atmospheres contained elements that should not have been there. Heavy elements such as iron, magnesium, calcium, silicon, and other materials that ought to sink beneath the visible surface relatively quickly. Something was continuously supplying fresh material. Something was still falling onto these dead stars. The question was obvious. Where was the material coming from? The answer turned out to be both beautiful and unsettling. Dead planets. Or more precisely, the remains of worlds that once orbited the star. Imagine a planetary system entering its final age. The parent star has already passed through the red giant phase. Its mass has changed. Its gravity has weakened. The surviving planets have shifted into new orbits. Asteroids and comets that once followed stable paths begin experiencing subtle disturbances. Over millions of years, gravitational interactions accumulate. Some objects drift inward, and eventually, one of them passes too close to the white dwarf. That is when the real destruction begins. The gravity of a white dwarf is extraordinary. Approach too closely, and tidal forces become overwhelming. The object is stretched, cracked, pulled apart. The world does not explode. It unravels, like a sculpture being slowly torn into dust. The debris forms a glowing ring around the dead star, a disk of shattered planetary material orbiting endlessly in silence. Astronomers have actually observed many of these debris disks, and when they look at them, they are effectively witnessing planetary graveyards, the remains of ancient worlds ground into cosmic dust, fragments of mountains, fragments of crust, perhaps even fragments of continents that existed billions of years before humanity appeared on Earth. The realization feels strangely emotional. Those rocks once belonged to entire worlds, worlds that may have experienced oceans, atmospheres, weather, moons, or histories completely unknown to us. Now, all that remains is a thin ring of debris circling a stellar corpse. Yet the story becomes even stranger, because sometimes astronomers can analyze the composition of this debris, and when they do, they occasionally discover familiar ingredients: iron, nickel, oxygen, silicates, the same basic materials that make up rocky planets like Earth. It is almost as if the universe is offering a glimpse into the anatomy of long-dead worlds. Like paleontologists reconstructing extinct creatures from scattered bones, astronomers reconstruct vanished planets from dust-orbiting white dwarfs. Every spectral line becomes a clue. Every chemical signature becomes evidence. A lost planet leaves behind a fingerprint. And remarkably, that fingerprint can survive long after the world itself has vanished. Some white dwarfs reveal evidence of planetary cores. Others seem to be consuming material resembling crusts or mantles. In a few cases, scientists suspect they may be observing the remnants of differentiated worlds, planets that once possessed layered interiors, much like Earth. That possibility is astonishing. It means some of the destroyed objects were not simple rocks. They were complex planetary bodies with long geological histories. Entire worlds lived, evolved, changed, and eventually died. Yet not every world in these graveyards is destroyed. Some survived. That may be the most surprising discovery of all. Astronomers have found evidence that certain planets continue orbiting white dwarfs billions of years after the death of their stars. Imagine standing on one of those survivors. The sky would be profoundly different. The blazing giant star that once dominated the heavens would be gone. In its place would hang a tiny, brilliant white ember, a stellar remnant no larger than Earth, the ghost of a former sun. The light would feel colder, the system quieter, the ancient catastrophe long finished. Yet the planet would still be there, still circling, still witnessing the slow cooling of the star's remains. The image feels almost poetic. Entire civilizations, if they ever existed, would have watched their sun transform, expand, die, and collapse into a white dwarf. Their descendants would inherit a completely different sky, a different universe. Yet the world beneath their feet might continue existing. Survival and destruction living side by side. That duality is what makes white dwarf systems so fascinating. They are not merely cemeteries. They are museums, archives, records of what happens after stellar death. They preserve both endings and survivors, both ruin and persistence. Every ring of dust tells the story of a world that was lost. Every surviving planet tells the story of one that endured. And together, they reveal something profound about the universe. Death rarely erases everything. Even after a star has exhausted its fuel, even after worlds have shattered, even after billions of years have passed, evidence remains. The debris keeps orbiting. The survivors keep circling. The graveyard stays visible, a silent monument to planetary histories stretching across cosmic time. If you're enjoying tonight's journey through these strange corners of the cosmos, take a moment to subscribe and join us for more explorations into the universe's most extraordinary mysteries. And perhaps leave a comment below telling me which strange world in astronomy fascinates you the most. Because among all the wonders we have discovered, there may be nothing more haunting than a dead star still surrounded by the memories of worlds that once called it home. 8. The planets that should not exist. Some planets should not exist. That statement may sound strange at first. After all, planets are common. Astronomers have discovered thousands of them. Every year brings new worlds, new systems, new possibilities. Yet among all those discoveries, a few planets stand out for a very different reason. Not because they are especially large, not because they are especially beautiful, but because they seem to violate the expectations of astronomy itself. They occupy places where our models say they should never have formed. They orbit stars that should have destroyed them. They exist in environments so hostile that their very presence feels like a challenge directed at our understanding of the universe. And perhaps that is what makes them so fascinating, because every time astronomers believe they understand the rules, the cosmos quietly produces another exception. Tonight, we journey into a collection of worlds that seem almost impossible, planets that should not exist, and yet somehow do. One of the first surprises arrived when astronomers began discovering giant planets orbiting astonishingly close to their stars. Before the 1990s, most scientists expected planetary systems to resemble our own. Rocky worlds near the star, gas giants farther away. That arrangement seemed logical. The intense heat near a young star should prevent enormous gas planets from forming. There simply should not be enough cool material available. Then, astronomers found something shocking. Gigantic planets, larger than Jupiter, orbiting closer to their stars than Mercury is to the Sun. Some complete an orbit in only a few days, others in less than a day. These worlds became known as hot Jupiters, and their discovery forced astronomers to rethink planetary formation entirely, because according to earlier models, they should never have been there. The temperatures are extreme. Their atmospheres are blasted by stellar radiation. Some are heated to thousands of degrees. Clouds of vaporized metals may drift through their skies. Rain, if it exists at all, may consist of molten material rather than water. Yet despite these impossible conditions, the planets remain. The solution appears to involve migration. Many scientists now believe these worlds formed farther away before slowly moving inward over millions of years. But even that explanation raises new mysteries. How exactly did they migrate? Why did some stop before falling into their stars? Why do some systems contain hot Jupiters while others do not? Each answer seems to generate new questions. The universe solved one mystery by creating several more. Then came another surprise: planets orbiting two stars. For generations, such worlds belonged mostly to science fiction. The idea seemed unstable. Two stars constantly pulling in different directions should make planetary formation extraordinarily difficult. Yet astronomers eventually discovered circumbinary planets, worlds orbiting around both stars simultaneously. Imagine standing on such a planet. Two suns rise into the sky. Two shadows stretch across the landscape. Daylight itself becomes more complicated. The gravitational environment is constantly changing. The stars dance around one another while the planet circles both. The arrangement appears almost theatrical. Yet these systems are real, and their existence revealed that planets can emerge in environments once considered too chaotic for orderly formation. Nature proved more flexible than theory anticipated. Then there are planets orbiting dead stars. At first glance, that may not sound impossible, but think carefully about what stellar death involves. Stars expand, they shed mass, some explode, others transform dramatically. The entire architecture of the planetary system changes. Many worlds are destroyed, others are ejected into interstellar space. The survival of any planet through such upheaval is remarkable. Yet astronomers continue finding evidence that some endured. Worlds orbiting white dwarfs, planets circling pulsars, entire systems rebuilt after stellar catastrophe. It is as though the universe refuses to let planetary stories end neatly. Even after death, new chapters continue. Some of the strangest examples may involve planets around pulsars. Pulsars are neutron stars, the collapsed remnants left behind after massive stars explode. They are among the most extreme objects in existence. Incredibly dense, rapidly rotating, flooding space with intense radiation. If there is anywhere planets should not exist, it is here. Yet the first confirmed exoplanets ever discovered were orbiting a pulsar. The discovery stunned astronomers. How could planets exist around such a violent object? Did they survive the supernova? Were they formed afterward from debris? Could entirely new planetary systems emerge from stellar wreckage? Even today, the answers remain incomplete, and that uncertainty only makes these worlds more intriguing. Perhaps the strangest lesson is that planets are far more resilient than we once imagined. Again and again, they appear where they seem least likely to survive, near dead stars, near multiple stars, near scorching stellar furnaces, even wandering alone through interstellar darkness. Every new discovery stretches the boundaries of possibility, and sometimes the impossible becomes surprisingly common. There is another category of planetary oddity that fascinates astronomers: planets orbiting extremely old stars. Some stars formed when the universe itself was young. Back when heavy elements were rare, traditional models suggested planet formation should be difficult under such conditions. Rocky worlds require heavy elements. Without enough carbon, oxygen, silicon, iron, and other materials, building planets becomes challenging. Yet observations suggest that planets may have formed far earlier than once believed. Some ancient stars appear to host planetary companions, despite existing in an era when the universe contained only a fraction of today's chemical richness. The implication is profound. Planet formation may have begun astonishingly early in cosmic history. Worlds may have existed while the Milky Way was still young, long before Earth formed, long before the sun ignited, long before most of the familiar stars filled the night sky. Perhaps entire generations of ancient worlds have already come and gone, lost to time before our planet even existed. The deeper astronomers look, the more difficult it becomes to define what a normal planetary system actually is. For decades, our solar system served as the primary template. It was all we knew. Naturally, we assumed other systems would look similar. Instead, the galaxy revealed endless creativity. Planets larger than expected, smaller than expected, hotter, colder, denser, lighter, orbiting one star, two stars, dead stars, or no stars at all. Every discovery expands the catalog of possibilities, and every possibility reminds us how little of the universe we have actually seen. That may be the most beautiful aspect of these impossible worlds. They teach humility, not because our theories are wrong, but because reality is often larger than our theories. The models describe patterns. Nature explores every exception. And somewhere tonight, beyond the reach of our telescopes, there may be worlds stranger than anything we have yet imagined. Planets hiding in places no astronomer has predicted. Worlds that would force us to rewrite entire chapters of planetary science. Because the universe has demonstrated this lesson repeatedly, whenever we become confident about where planets can exist, the cosmos quietly creates one where they shouldn't, and waits for us to discover it. 9. Worlds heated by nothing but their own hearts. Most worlds depend on stars. Without a sun, a planet should become cold, dark, silent, dead. That assumption feels so natural that we rarely question it. Every source of warmth we know ultimately traces back to the sun. The oceans, the winds, the forests, the weather. Even the energy stored in ancient fossils was once sunlight. Remove the star and the system appears doomed. The light fades, the heat vanishes, life ends. At least that is what common sense suggests. But the universe has a habit of hiding exceptions in the darkness. And some of the most fascinating exceptions are worlds that continue to stay warm long after their connection to starlight has weakened or disappeared entirely. These are worlds heated by their own hearts, planets whose deepest interiors refuse to cool, worlds carrying ancient fires hidden beneath frozen surfaces, and in some cases, places that may remain active for billions of years, even while drifting through eternal night. The idea sounds almost impossible. How can a planet stay warm without a star? The answer begins deep underground. Every rocky world is born hot, violently hot. When planets form, countless collisions release enormous amounts of energy. Asteroids crash together. Planetary embryos merge. Matter falls inward under gravity. The young world becomes molten. An ocean of magma may cover its entire surface. For a time, planets are closer to stars themselves than to the quiet worlds we see today. Over millions and billions of years, much of that heat escapes into space, but not all of it. Deep within a planet, ancient warmth can remain trapped, like embers buried beneath ash, slowly cooling, slowly fading, yet sometimes never fully disappearing. Even Earth still carries part of its primordial heat. Far beneath your feet, temperatures rise dramatically with depth. The deeper you travel, the hotter the planet becomes. Eventually, rock softens, then partially melts, and finally approaches conditions almost impossible to imagine from the surface. Earth's core remains incredibly hot. Its internal energy helps drive volcanism, plate tectonics, magnetic fields, and many of the geological processes that shape our world. In a sense, Earth is still slowly releasing heat generated billions of years ago. The planet remembers its birth. But primordial heat is only part of the story. Another source of planetary warmth comes from radioactivity. Hidden within rocks are unstable elements: uranium, thorium, potassium. As these elements decay, they release energy. The process is incredibly slow, yet across an entire planet, the effect becomes significant. Billions upon billions of tiny atomic transformations generate a continuous supply of internal heat, invisible, silent, persistent. For geological timescales, radioactive decay acts like a hidden furnace operating deep beneath the crust. Long after sunlight disappears, that furnace may continue burning, and suddenly the idea of a warm world in darkness no longer seems quite so impossible. Some of the best examples exist within our own solar system. Take Jupiter's moon, Europa. At first glance, Europa appears frozen. Its surface is covered by vast plains of ice. Temperatures are brutally cold. Sunlight reaching Jupiter is already far weaker than what Earth receives. Yet beneath Europa's icy shell, scientists strongly suspect the existence of a global ocean. An ocean hidden beneath kilometers of ice. Liquid water surviving where none should exist. The secret is not sunlight. The secret is tidal heating. Europa is constantly squeezed by Jupiter's immense gravity. As the moon travels along its orbit, gravitational forces flex its interior. The entire moon is gently stretched and compressed, again and again, endlessly. That flexing generates heat. The process is similar to bending a metal wire repeatedly until it becomes warm, only on a planetary scale. Deep inside Europa, gravity itself becomes a source of energy. And that energy may be enough to maintain an ocean larger than all of Earth's oceans combined. The implications are extraordinary, because where liquid water exists, the possibility of life inevitably enters the conversation. And Europa is not alone. Another moon, Enceladus, orbiting Saturn, offers an even more dramatic example. This tiny, icy world should be frozen solid. Instead, giant geysers erupt from fractures near its south pole. Water vapor, ice particles, organic compounds, all blasting into space. Some of these plumes rise hundreds of kilometers above the surface. The source appears to be a hidden subsurface ocean, again maintained not by sunlight, but by internal energy. Imagine standing on such a world. Above you, the sky is almost black. The sun appears only as a distant, bright star. Yet beneath your feet, an ocean remains alive with motion. Currents circulate, water flows, heat escapes from the interior. The world seems frozen from the outside, but inside it remains active, a secret hidden beneath ice. Perhaps the strangest possibility involves rogue planets, worlds that no longer orbit any star at all. Planets wandering alone through interstellar space. These worlds drift through darkness deeper than anything found inside a normal planetary system. No sunrise, no sunset, no seasons. Only endless night. At first, such worlds seem completely hopeless. Yet some scientists have suggested that large rogue planets could retain enough internal heat to remain surprisingly interesting. If a thick atmosphere traps geothermal energy efficiently enough, surface conditions might remain far warmer than expected. Beneath ice layers, liquid oceans could potentially survive for billions of years. Life, if it ever emerged, might continue completely independent of starlight, powered instead by chemistry and geothermal energy. The idea feels almost unsettling. We instinctively associate life with sunlight, plants, photosynthesis, bright skies, warm afternoons. Yet nature may not require any of those things. Life on Earth already thrives around deep-sea hydrothermal vents, where sunlight never reaches. Entire ecosystems survive using chemical energy emerging from Earth's interior. Perhaps somewhere in the galaxy, similar ecosystems exist beneath frozen crusts, entire biospheres hidden under kilometers of ice, never seeing a sunrise, never knowing a star, living entirely from the heat rising below. The deeper astronomers explore, the more they discover that warmth is not always tied to light. A planet can glow internally long after its skies grow dark. It can remain geologically active long after its star fades. It can preserve liquid water beneath frozen surfaces for astonishing lengths of time. The universe keeps revealing hidden reservoirs of energy where we least expect them, and perhaps that changes the way we think about habitability itself. Maybe the most important worlds are not always the bright ones, not always the worlds bathed in sunshine, not always the planets with blue skies and visible oceans. Some may exist in darkness, wrapped in ice, far from any star, their warmth hidden deep underground, their oceans concealed beneath frozen shells, their stories invisible from a distance. Yet inside, they continue living their secret lives, because a world does not always need a sun to stay alive. Sometimes the fire that matters most is the one burning quietly within, and long after the light has gone out above, that hidden heart may continue beating in the dark. 10. The cosmic orphans left behind. The destruction of a star does not always end with the star itself. Sometimes, long after the catastrophe has passed, something remains. A lonely world, a survivor, a planet that once circled a stable sun, basking beneath familiar light, following a predictable orbit through space. Then the system broke apart. The star died. The gravity changed. The architecture of an entire solar system collapsed. And somehow, the planet remained. These are the cosmic orphans left behind, and their stories may be among the saddest and most fascinating in the universe. For most of a planet's life, its identity is tied completely to its star. The star provides warmth, light, energy, stability, the rhythms of day and night, the possibility of weather, the conditions that shape every surface and atmosphere. A planet without a star almost seems impossible to imagine. Yet throughout the galaxy, stars are constantly changing. Some expand, some explode, some are stolen by neighboring stars, some are thrown from their birthplaces entirely. And when that happens, planets can suddenly find themselves alone. Astronomers once assumed that planetary systems were relatively stable. Stars formed, planets formed around them. The systems slowly evolved. The story seems straightforward, but modern astronomy has revealed something much messier. The galaxy is not a peaceful neighborhood. Stars drift, clusters dissolve, binary systems interact, gravitational encounters occur, and entire planetary systems can be disrupted. In this dynamic universe, not every planet gets to keep its parent star forever. Some become separated, some are abandoned, some are cast adrift. The result is a population of worlds that no longer belong anywhere, cosmic orphans. And remarkably, there may be billions of them. One way a planet becomes orphaned is through stellar death. Imagine a star similar to our Sun. For billions of years, it shines steadily. Its planets orbit in familiar paths. Then, eventually, the hydrogen fuel in its core begins to run low. The star swells into a red giant. Its outer layers expand outward. Inner planets may be consumed. Atmospheres may be stripped away. Orbits shift as the star loses mass. The entire system becomes unstable. When the outer layers finally drift into space, the star shrinks into a white dwarf. What remains is only the tiny exposed core. The original star is gone. Its planetary family is forever changed. Some planets survive, but survival does not mean life continues normally. The sky above them is no longer the same. The warm yellow sun that dominated their heavens has vanished. In its place sits a tiny white ember, a stellar corpse. The planet still orbits something, yet the parent it once knew has disappeared. In a very real sense, it has become an orphan. Other worlds experience even greater violence. Massive stars do not fade gently. They die in explosions. Supernovae release unimaginable amounts of energy. For a brief moment, a single dying star can outshine entire galaxies. The blast wave tears through nearby space. Radiation floods surrounding planets. Atmospheres may be stripped away. Surfaces may be sterilized. Entire worlds may be shattered. And yet some planets appear capable of surviving even these catastrophic events. Astronomers have discovered planets orbiting neutron stars, the crushed remnants left behind after supernova explosions. These systems are astonishing. They suggest that somehow, against overwhelming odds, planetary bodies endured one of the most violent events in the cosmos, or perhaps formed again afterward from the debris. Either possibility is extraordinary. A world circling a neutron star lives beneath skies unlike anything Earth has ever known. No warm sunrise, no familiar daylight. Only the eerie glow of a stellar remnant that once exploded with enough force to destroy nearly everything around it. Yet the orbit continues. The planet remains, still circling, still existing, long after its parent star has effectively died. But perhaps the most extreme orphans are not those that remain near stellar remnants. Perhaps they are the worlds that lose their stars entirely. To understand how this happens, we need to remember that stars rarely live alone. Many stars form in clusters, thousands of young suns crowded together, each moving through space under the influence of all the others. In such crowded environments, gravitational encounters are common. Most are harmless. Some are not. A close stellar flyby can dramatically alter planetary orbits. A passing star may tug on distant planets, or destabilize an entire system. Over millions of years, those disturbances accumulate. Sometimes a planet is pulled onto a new path. Sometimes it is flung outward forever. And sometimes it escapes completely. No star, no home. only interstellar darkness. The planet becomes a rogue world, a cosmic orphan wandering the galaxy alone. This process may be far more common than once believed. Computer simulations suggest that planetary ejections occur frequently during the chaotic early years of solar systems. Young giant planets migrate, gravitational interactions become violent, massive worlds scatter smaller ones, orbits cross, collisions occur. Eventually, one planet receives a final gravitational kick. Its velocity increases, its orbit opens, and it leaves forever. The star shrinks behind it. The system disappears. The orphan begins a journey that may last billions of years. Imagine standing on such a world. There is no sunrise, no sunset, no familiar star hanging overhead. The sky is almost completely black. Nearby stars appear only as distant points. The planet drifts endlessly through interstellar space. And yet, it may not be entirely dead. That possibility is one of the most surprising discoveries in modern planetary science. For decades, astronomers assumed rogue planets would quickly freeze solid. Without starlight, how could they remain active? How could anything survive? The answer may lie deep beneath the surface. Planets possess internal heat. Radioactive decay generates energy. Residual formation heat can linger for billions of years. Massive atmospheres may trap warmth. Subsurface oceans might remain liquid, even without a sun. Even without daylight. Life, if it exists, might not require a star at all. Some researchers have proposed that orphan worlds could host hidden oceans beneath thick shells of ice. Dark ecosystems powered entirely by internal energy. No sunlight, no seasons, no blue skies, only endless night. And perhaps life quietly enduring below. If such worlds exist, they would challenge one of humanity's oldest assumptions, that stars are necessary for habitable environments. The universe may be stranger than that. A planet does not always need a parent. A world does not always need sunlight. Life itself may prove more adaptable than we ever imagined. What makes cosmic orphans so emotionally powerful is that they force us to rethink what it means to belong. We naturally imagine planets as members of families, stars at the center, planets circling around them, order, structure, connection. Yet the galaxy repeatedly shows us another possibility. Worlds separated from their origins, worlds surviving after catastrophe, worlds continuing their journeys alone. There is something strangely moving about that image. A solitary planet crossing the darkness between stars. No home system, no familiar sun. Only momentum carrying it forward through the vastness of space. And yet it continues, still existing, still traveling, still part of the universe. Perhaps that is the deeper lesson of these cosmic orphans. The universe does not guarantee permanence. Stars die, systems break apart, paths change, families separate. Yet existence continues, sometimes in forms we never expected. Sometimes in places we never imagined. And somewhere tonight, beyond the reach of any telescope powerful enough to reveal every secret, countless orphan worlds are likely drifting through the darkness, silent, unseen, homeless, yet still carrying their histories with them. Tiny survivors wandering the endless night between the stars. 11. Hidden oceans beneath frozen skies. Before astronomers began searching the outer reaches of the solar system in detail, there was a simple assumption about where life might exist. Find a planet close enough to a star, find liquid water on its surface, find sunlight, and perhaps life could emerge. Everything seemed to depend on the warmth of a nearby sun. But the universe has a habit of challenging simple assumptions. And one of the greatest surprises arrived not from distant exoplanets, but from frozen worlds orbiting our own sun. Worlds that appeared completely dead. Worlds covered in ice. Worlds so cold that sunlight barely touched them. And yet beneath their frozen surfaces, entire oceans may be hiding. Vast oceans. Dark oceans, ancient oceans, perhaps oceans that have existed longer than some seas on Earth. Tonight we descend beneath those frozen skies, into places where darkness reigns, but where water may still flow. Because a world can look like a lifeless ball of ice, while beneath it lies an ocean larger than anything on Earth. At first glance, these worlds seem completely inhospitable. Far from the sun, temperatures plunge far below freezing. The surface becomes locked beneath thick shells of ice. Mountains of frozen water stretch toward black horizons. No rain falls, no rivers flow, no waves crash onto beaches. Everything appears still, frozen, silent. The kind of place where life should be impossible. Yet appearances can be deceiving. Rare stars taught us that a star's surface does not always reveal its true history. Frozen worlds teach a similar lesson. A planet or moon does not always reveal what lies beneath. Sometimes the most active places in the solar system are hidden under the thickest layers of ice. The first hints emerged from observations of a small moon orbiting Jupiter, a world known as Europa. From a distance, Europa appears smooth and bright. Its surface is covered almost entirely by water ice. Cracks spread across the landscape like scars. Long, dark lines stretch for thousands of kilometers. At first, scientists wondered whether these features were simply fractures in a frozen crust. But the more they studied Europa, the stranger it became. The surface seemed remarkably young, too young. Impact craters were surprisingly rare. Something appeared to be constantly renewing the ice. Something was erasing old scars. Something beneath the surface was influencing the world above. Eventually, evidence began pointing toward an astonishing possibility. Beneath Europa's frozen shell may lie a global ocean. Not a lake, not a sea. An ocean covering the entire moon. And that ocean may contain more water than all of Earth's oceans combined. Imagine standing on Europa. Above you hangs Jupiter, enormous and glowing in the darkness. Beneath your feet stretches kilometers of solid ice. Everything seems frozen. Everything seems dead. Yet far below, an entire hidden ocean may be moving through darkness. Currents, tides, possibly hydrothermal activity. An unseen world concealed beneath a frozen sky. And Europa is not alone. Around Saturn circles another remarkable moon, a moon called Enceladus. At first, Enceladus seemed insignificant, tiny compared with larger moons, bright and icy, easy to overlook. Then something extraordinary happened. Spacecraft observed giant plumes erupting from its south pole, jets of water vapor, ice particles, organic molecules, material blasting hundreds of kilometers into space. It was one of the most important discoveries in planetary science. Because those plumes appeared to be coming directly from an underground ocean, for the first time, humanity had direct evidence that liquid water existed beneath an icy world. Not in the distant past, not as a theoretical possibility, but right now, at this very moment. Deep beneath Enceladus's frozen crust, an ocean may still exist. And more remarkably, scientists detected ingredients often associated with potentially habitable environments. Water, organic compounds, chemical energy, the building blocks of complexity. Suddenly, one of the most promising places to search for extraterrestrial life was no longer a warm, Earth-like planet. It was a frozen moon, a tiny world hidden beneath layers of ice. This realization transformed planetary science. Because if Europa and Enceladus possess hidden oceans, how many others might exist? The answer may be surprising. Quite a few. Ganymede, Callisto, Titan, perhaps Triton around Neptune, possibly even dwarf planets far beyond Neptune's orbit. Many icy worlds may conceal liquid interiors. The outer solar system might contain a vast collection of hidden oceans, entire aquatic environments concealed beneath frozen shells. And the reason they survive is fascinating. The source of their warmth is not sunlight. It is gravity. As moons orbit giant planets, gravitational forces constantly flex and squeeze them. The process is known as tidal heating. A moon is stretched, compressed, bent, over and over again. The constant flexing generates internal heat, like repeatedly bending a metal wire until it becomes warm. That energy can melt ice deep below the surface, maintaining liquid oceans for billions of years. Even in regions where sunlight is weak and temperatures are unimaginably cold, This changes how we think about habitability. For generations, astronomers focused on the habitable zone, the region around a star where liquid water might exist on a planet's surface. The concept remains important, but hidden ocean worlds reveal another possibility. A world does not necessarily need surface oceans. It may not need warm skies. It may not even need direct sunlight. The ingredients for habitability can exist underground, protected beneath kilometers of ice, shielded from radiation, hidden from view. In some ways, these buried oceans may be more stable than Earth's surface environments. Earth experiences climate shifts, asteroid impacts, atmospheric changes, solar fluctuations. But an ocean sealed beneath a thick ice shell may remain remarkably insulated, protected from many external disturbances for billions of years. That longevity raises a profound question. If life can emerge in such environments, could it survive for immense stretches of time, perhaps longer than civilizations, longer than continents, longer than many stars remain stable? The thought is both strange and beautiful. Somewhere beneath a frozen crust, darkness may have persisted uninterrupted for billions of years. No sunrise, no sunset, no sky. Only an ocean existing in eternal night. And yet life on Earth offers an intriguing clue. At the bottom of our own oceans are hydrothermal vents, cracks in the seafloor where heat from Earth's interior escapes into the water. Around these vents thrive entire ecosystems, creatures that do not depend directly on sunlight. Instead, they rely on chemical energy. For scientists, these environments are tantalizing because hidden ocean worlds may possess something similar. Rocky interiors, liquid water, internal heat, chemical reactions, the same ingredients that support life in some of Earth's darkest environments. No one knows whether life exists beneath Europa's ice, or within Enceladus's ocean, or inside any hidden sea elsewhere in the cosmos. But the possibility remains one of the most exciting questions in modern science. Because if life can emerge beneath frozen worlds, then habitable environments may be far more common than we once believed. Entire ecosystems could exist in places that appear utterly barren from above. Worlds we once dismissed as frozen wastelands may instead be vibrant beneath the surface. That idea changes how we see the universe. A frozen landscape no longer means a dead world. Silence does not necessarily mean emptiness. Darkness does not necessarily mean lifelessness. The universe may be full of hidden places, places concealed beneath ice, protected beneath ancient crusts, waiting patiently beyond the reach of sunlight. And perhaps that is the deepest lesson of these ocean worlds. Reality often hides beneath appearances. A frozen surface can conceal warmth. A silent world can conceal activity. An empty horizon can conceal possibility. Far beneath frozen skies, oceans may be moving even now. Currents flowing through darkness, water touching ancient rock, energy passing quietly through unseen ecosystems. And somewhere out there, beneath kilometers of ice and endless night, an entire world may be alive without ever seeing a sunrise. 12. Ancient worlds older than Earth. There is something strangely humbling about the age of Earth, 4.5 billion years. That number alone feels almost impossible to grasp. Entire mountain ranges have risen and vanished. Oceans have opened and closed. Countless species have appeared and disappeared. Life itself has transformed the planet over spans of time so vast that human history becomes nearly invisible by comparison. And yet, in the scale of the universe, Earth may not be especially old. In fact, somewhere among the stars, there may be worlds that were already ancient when our planet was still nothing more than dust orbiting a young sun. Worlds that witnessed the early chapters of the galaxy. Worlds that have survived for billions upon billions of years. Worlds older than Earth, and perhaps much older than we usually imagine. Tonight we travel into the deep past of the cosmos, far beyond human history, far beyond the age of civilizations, back toward a time when the universe itself was still young. Because some planets may have been quietly orbiting their stars for longer than our entire solar system has existed. To understand how this is possible, we first need to remember something surprising. The universe is ancient. Current estimates place its age at roughly 13.8 billion years. Earth formed only about 4.5 billion years ago. That means nearly 2/3 of cosmic history had already passed before our planet even existed. For billions of years before Earth formed, stars were already being born, living their lives and dying. Galaxies were evolving. Heavy elements were accumulating. Entire generations of stars had already come and gone. The cosmos had a very long head start, and wherever stars existed, planets may eventually have followed. This was not always obvious. For much of the 20th century, astronomers did not know whether planets were common or rare. The first confirmed exoplanets were discovered only a few decades ago. Before then, we had a sample size of exactly one planetary system, our own. But modern discoveries have completely changed that picture. Planets appear to be everywhere. Small planets, giant planets, hot worlds, frozen worlds, systems packed with multiple planets, systems unlike anything we expected. The galaxy seems extraordinarily efficient at making worlds, and that realization leads to a profound possibility. If planets have been forming throughout cosmic history, then some of them must be vastly older than Earth. Imagine a star born 10 billion years ago. Perhaps it formed when the Milky Way was still young. Perhaps it emerged from clouds enriched by earlier generations of stars. If planets formed around that star, they too could be nearly 10 billion years old. More than twice Earth's age. A world that ancient would possess a history almost beyond imagination. While Earth was still waiting to form, such a planet might already have completed billions of orbits. Its continents, if it had any, might have shifted countless times. Its climate might have changed repeatedly. Entire geological eras could have unfolded before our sun even ignited. And some candidates may be even older. One of the most fascinating discoveries involves planets orbiting extremely old stars. Some stars belong to populations that formed early in the history of the Milky Way. These stellar elders act like archaeological relics. They preserve clues about conditions billions of years ago. When astronomers find planets around such stars, it becomes clear that planet formation began surprisingly early in cosmic history. The universe did not wait for Earth. It had already been experimenting with worlds long before our solar system arrived. That thought can feel almost unsettling. When we look at Earth, we often think of it as ancient, and by human standards, it certainly is. But compared with some possible exoplanets, Earth may be relatively young, a newcomer, a late arrival, a child in a galaxy filled with far older worlds. Imagine standing on such a planet. The night sky would tell a different story. The galaxy itself would have looked different when that world formed. Some stars visible today would not yet exist. Entire stellar populations would still be unborn. The Milky Way would have been younger, less settled, more chaotic. And yet that planet might still be there now, still orbiting, still enduring, a survivor of nearly unimaginable stretches of time. The deeper astronomers look, the more remarkable this possibility becomes. Age is not merely a number. Age changes everything. An ancient world has had more time for geology, more time for climate evolution, more time for orbital changes, and, if life exists, more time for biology. This is one reason old planets fascinate scientists. On Earth, life emerged relatively quickly after conditions stabilized. Within a few 100 million years, simple organisms were already present. Over billions of years, those organisms evolved into increasingly complex forms. Eventually, intelligence appeared, at least once. If similar processes occur elsewhere, then ancient worlds might have enjoyed an extraordinary advantage. They may have had billions of additional years for evolution to work. Billions. Not thousands, not millions. Billions. The difference is staggering. A civilization only 1 million years older than humanity would already seem almost unimaginable. Now consider a world that formed billions of years before Earth. The possibilities become almost impossible to visualize. Of course, age alone guarantees nothing. Ancient planets face challenges as well. Stars change over time. Some become brighter, others evolve dramatically. Radiation environments shift. Planetary atmospheres may erode, water may be lost, habitability may disappear. Longevity does not necessarily mean stability. Yet some worlds may persist through astonishing spans of time, particularly around smaller stars. Red dwarfs burn fuel incredibly slowly. Some may survive for trillions of years, far longer than the Sun. If planets orbit such stars, they may enjoy lifetimes vastly exceeding anything available within our solar system. Earth's habitable future may last another billion years or so. A suitable planet around a stable red dwarf could potentially remain habitable for much longer. The future of such worlds stretches into depths of time that almost defy comprehension. And perhaps that is the most beautiful aspect of ancient planets. They expand our perspective. Human beings naturally think in decades. Civilizations think in centuries. History thinks in millennia. Planets force us to think in billions of years. Ancient planets push even further. They remind us that the universe has been unfolding for far longer than our own story. There were worlds before Earth. There may be worlds that will outlive Earth. And somewhere tonight, beneath unfamiliar skies orbiting distant stars, there may be planets whose histories began when the universe was still young. Worlds that have witnessed ages beyond counting. Worlds older than mountains, older than oceans, older than the sun itself. Silent travelers carrying memories written across billions of years. If the stories hidden within deep cosmic time fill you with wonder, consider saving this video so you can continue exploring the universe on another quiet night. Because the farther we travel into the cosmos, the more we discover that Earth is not the beginning of the story. It is simply one chapter. And somewhere in the darkness, far older chapters are still waiting to be read. 13. The last planets of dying galaxies. Imagine looking up at a night sky billions of years from now. Not millions, not even trillions. A future so distant that every human civilization, every mountain on Earth, every familiar star in the sky has long since vanished into history. And yet somewhere in that unimaginable darkness, a few lonely planets may still remain. Still orbiting, still drifting, still carrying the fading memories of a universe that was once bright with countless suns. Tonight, we travel to one of the strangest questions in all of astronomy. What happens to planets when galaxies themselves begin to grow old? Because galaxies age, not in the way living creatures do. They do not wrinkle or weaken, but over vast stretches of time, the great engines that create new stars slowly begin to shut down. The gas clouds that once fueled stellar birth become depleted. Collisions consume resources. Radiation alters environments. And gradually, the brilliant spiral structures that define young galaxies begin to quiet. The universe enters a slower chapter, a calmer chapter, a darker chapter. And in that distant future, some planets may become the last surviving witnesses to an era of cosmic abundance. To understand these final worlds, we first need to understand how galaxies change over time. Right now, our home galaxy, the Milky Way, is still actively forming stars. Giant molecular clouds drift through its spiral arms. Within those clouds, gravity pulls hydrogen together. New stars ignite, new planetary systems emerge. The cycle continues. Birth follows birth, generation after generation. But this process cannot continue forever. Every new star consumes part of the available supply. Every stellar wind pushes material away. Every supernova rearranges the balance. Eventually, the raw ingredients become increasingly scarce. Astronomers sometimes describe this as stellar population aging. The youngest galaxies are energetic and productive. Older galaxies become quieter. Their brightest periods lie in the past. And when enough time passes, the creation of entirely new planetary systems may become exceedingly rare. Imagine living inside such a galaxy. The sky would look different, not because stars disappear immediately. Most stars survive for enormous lengths of time, especially the smallest ones. But the sky would gradually lose something important: novelty, the constant arrival of new suns. The galaxy would become a place defined less by creation and more by endurance. And that is where the story of the last planets begins. because the final planets of aging galaxies will likely orbit the longest-lived stars in existence, tiny red dwarfs. These humble stars receive far less attention than giant blue stars or spectacular supernovae. They do not dominate photographs. They rarely steal headlines. Yet they possess something extraordinary: patience. A red dwarf burns its fuel with remarkable efficiency. While stars like our Sun survive for roughly 10 billion years, some red dwarfs may continue shining for trillions of years. Not billions, trillions. Long after larger stars have exhausted themselves. Long after many galaxies have entered their quiet old age, these small stars may remain, and so may the planets orbiting them. If a civilization somehow existed around one of these stars, its descendants might witness a universe unlike anything we know today. Many of the bright stellar giants visible in our era would be gone. The cosmos would feel calmer, older, more subdued. Yet their small red sun would continue glowing steadily in the darkness, providing warmth, providing light, providing continuity. In a sense, these worlds could become the retirement homes of the cosmos. Not because they are unimportant, but because they survive after most of the drama has ended. There is something strangely comforting about that idea. The universe often appears violent. Stars explode, galaxies collide, black holes consume matter. Yet some worlds may persist quietly through all of it, holding their orbits, keeping their seasons, watching the ages pass. But even these survivors cannot last forever, because galaxies themselves continue evolving. One day, the Milky Way and the neighboring Andromeda galaxy are expected to merge. The event will unfold slowly over billions of years. Stars will rarely collide directly. Space is far too empty for that. Yet gravitational interactions will reshape both galaxies. Entire planetary systems may experience subtle disturbances. Orbits could change. Some worlds may be flung outward. Others may drift inward. A few might even become cosmic orphans, wandering intergalactic space. And still, some planets will survive. That resilience appears again and again throughout astronomy. Worlds endure events that seem impossible. They survive stellar deaths. They survive orbital chaos. They survive gravitational upheaval. Again and again, planets prove remarkably difficult to erase completely. Which raises a fascinating possibility. The last planets of dying galaxies may not necessarily orbit stars at all. Some could be rogue planets, worlds wandering freely through darkness. No sunrise, no sunset, no parent star, only endless night. At first, such planets sound lifeless, frozen, dead. Yet reality may be more complicated. Many rogue planets could retain internal heat. Radioactive elements buried deep inside their interiors might continue releasing energy. Subsurface oceans could remain liquid beneath thick shells of ice. Life, if it ever emerged, might find refuge far below the surface. Protected from the cold, protected from radiation, protected from the changing universe above. In that scenario, the last habitats in an aging galaxy might not be bright worlds under shining suns. They might be hidden oceans beneath frozen skies. Silent ecosystems surviving in darkness, waiting while the stars gradually disappear. And perhaps the strangest thought arrives when we imagine time moving even farther forward, far beyond the era of normal galaxies, far beyond familiar astronomy. Many stars will eventually become white dwarfs. Others will become neutron stars. Some will collapse into black holes. The bright universe we know today will slowly transform into a population of stellar remnants. The cosmos will not suddenly go dark, but it will grow quieter, older, less luminous. Yet planets may still remain, some orbiting white dwarfs, some orbiting red dwarfs, some wandering alone, each carrying the history of countless previous ages. In a way, these worlds become cosmic archives. They remember eras that no longer exist. The atoms within them were forged by stars long gone. Their landscapes were shaped by events forgotten by the wider universe. Their existence becomes evidence that creation happened at all. And that idea feels surprisingly profound, because astronomy often focuses on beginnings, the birth of stars, the birth of galaxies, the birth of planets. But the last planets of dying galaxies remind us to think about endings, not as sudden disappearances, but as transformations, as long fading echoes, as stories that continue long after the main chapter has ended. Perhaps somewhere in the unimaginable future, a small rocky world will still orbit a dim red dwarf. The galaxy around it will be older than anything we can truly comprehend. Most stars will belong to history. The great age of creation will have passed. Yet that world will remain, turning quietly around its ancient sun, a final survivor beneath a darkening sky. And in that distant future, the universe may feel less like a place of beginnings and more like a vast archive of memories, a place where the last planets continue their endless journey through time. Not because they were the most powerful worlds ever created, but because they endured the longest. 14. Could life outlive the stars? Life on Earth depends on the sun. Every forest, every ocean, every breath you take ultimately traces its energy back to a star burning nearly 150 million kilometers away. For as long as humanity has looked at the sky, there has been an almost invisible assumption hidden beneath our understanding of life. Stars create life. Stars sustain life. And when stars die, life dies with them. At first glance, that seems obvious. Without sunlight, Earth would freeze. Photosynthesis would stop. Food chains would collapse. The oceans would eventually grow dark and cold. The sun appears so fundamental to life that imagining biology without a star feels almost impossible. But the deeper astronomers explore the universe, the stranger the question becomes. What if life is more resilient than we think? What if stars are not the only path to survival? And what if, somewhere in the unimaginably distant future, life continues long after most of the universe's suns have faded away? Tonight, we follow one of the most fascinating possibilities in all of astrobiology. Could life outlive the stars themselves? The answer begins deep beneath the ice, because one of the most surprising discoveries in our own solar system is that sunlight is not always necessary for liquid water. Take the moon Europa. From a distance, Europa looks frozen and lifeless. Its surface is covered in ice. Temperatures plunge far below anything comfortable for life as we know it. Yet beneath that frozen shell, scientists believe a vast global ocean may exist. An ocean containing more water than all of Earth's oceans combined. The source of that heat is not sunlight. It comes from gravity. As Europa orbits giant Jupiter, tidal forces continuously flex and squeeze the moon's interior. That constant motion generates heat, enough heat to keep water liquid beneath the ice. The same may be true for Enceladus, where giant plumes of water vapor erupt into space from hidden reservoirs below the surface. These worlds hint at something extraordinary. Life may not require direct starlight at all. Instead, it might survive using internal planetary energy. And if that is true, the lifespan of life becomes much longer than the lifespan of stars. Imagine a rogue planet drifting through interstellar darkness. No sun, no daylight, no seasons. At first glance, it seems completely hopeless. Yet beneath a thick insulating atmosphere or an enormous shell of ice, internal heat could remain trapped for billions of years. Radioactive elements buried deep inside the planet would continue releasing energy. Geothermal vents might warm underground oceans. Chemical gradients could provide fuel for microbial ecosystems. In such a world, life would never see a sunrise. It would never know stars. Its entire existence would unfold in darkness, and yet it could still survive. That possibility changes everything, because suddenly the death of a star no longer guarantees the death of every living thing nearby. Instead, some forms of life may simply retreat underground. They may adapt, hide, persist. The universe repeatedly rewards persistence. Life on Earth has survived asteroid impacts, global ice ages, mass extinctions, supervolcanoes, continental rearrangements. Again and again, biology proves remarkably difficult to erase completely. If life emerges elsewhere, perhaps it possesses similar resilience. Perhaps civilizations vanish while microbial ecosystems endure. Perhaps oceans freeze at the surface while life continues below. Perhaps entire biospheres retreat into subterranean refuges when stars begin to fail. And that leads us toward one of the strangest futures imaginable, the era of red dwarfs. Today, the universe is still relatively young. Massive stars shine brilliantly. Medium-sized stars like the Sun remain common. Galaxies continue producing new generations of stellar systems. But over enormous spans of time, the longest-lasting stars become increasingly important. Red dwarfs. These tiny stars burn fuel incredibly slowly. Some may survive for trillions of years. To appreciate that number, remember that the universe itself is only about 13.8 billion years old. A trillion years is vastly longer. These stars may continue providing energy long after stars like our Sun have disappeared. If planets orbit such stars, life may enjoy opportunities that Earth never will. Imagine civilizations with trillions of years available for development, trillions of years for evolution, for adaptation, for discovery. Entire histories beyond anything our species can currently comprehend. The future universe may belong not to bright stars like the Sun, but to countless dim red dwarfs quietly burning through unimaginable ages. Yet even they cannot last forever. Eventually, every star runs out of fuel. Even the most patient suns reach an ending. And when that happens, the question becomes even stranger. Could life survive after the final stars die? At first, the answer seems impossible. Without stars, where does energy come from? Life requires energy. Without a source, no biological process can continue indefinitely. Yet the universe contains more possibilities than sunlight alone. Black holes store enormous energy. Neutron stars release heat. White dwarfs cool slowly across unimaginable timescales. Gravitational interactions continue. Radioactive decay continues. Even the faint background heat of the universe evolves over time. Future forms of life, if they exist, may learn to exploit energy sources that seem exotic to us today. Perhaps advanced civilizations migrate from dying star to dying star. Perhaps they build habitats around white dwarfs. Perhaps they extract energy from black holes. Perhaps they engineer entirely artificial environments, independent of any natural sun. This idea appears repeatedly in theoretical discussions about the far future, not because we know such civilizations exist, we do not, but because intelligence introduces flexibility. A forest cannot relocate when its star dies. A technological civilization might. The longer life survives, the more opportunities it has to adapt. And adaptation is often life's greatest strength. Yet even beyond technology lies another possibility. Perhaps life becomes slower, much slower. In a colder universe, biological processes might stretch across enormous timescales. What feels like a year to us might become thousands of years to some future organism. Metabolism slows, growth slows, thought itself may slow, but survival continues. The universe's fading light does not necessarily demand immediate extinction. Instead, it may encourage patience, a different rhythm, a slower existence matched to an aging cosmos. There is something almost poetic about that vision. Life beginning beneath bright young stars, then gradually adapting as the universe changes around it, passing through different cosmic eras, different environments, different sources of energy, always adjusting, always finding another path forward, because that may be the deepest lesson nature teaches. Life rarely survives by remaining unchanged. It survives by transforming. The earliest organisms on Earth could never have imagined forests. The first fish could never imagine birds. The first mammals could never imagine cities. Yet life continued adapting to circumstances that constantly shifted. Perhaps the same principle applies on cosmic scales. Perhaps the death of stars is not necessarily the end of life's story. Perhaps it is simply the end of one chapter. And if that is true, then the future becomes far stranger than we usually imagine. Instead of a universe where life disappears when stars fade, we may envision a universe where life follows the stars into darkness, changing form, changing habitat, changing pace, but continuing. Somewhere beneath frozen oceans, somewhere around dim stellar remnants, somewhere orbiting ancient red dwarfs, or perhaps somewhere we have not yet learned to imagine. Because the universe has surprised us many times before, and whenever we assume we know the limits of possibility, nature often reveals another hidden door. So perhaps the better question is not whether life can outlive the stars. Perhaps the better question is how many different ways life might discover to endure after the stars are gone. And as the night grows quieter around you, it is comforting to remember that survival is one of the oldest stories in the cosmos. Stars survive, planets survive, galaxies survive, and perhaps, if the universe allows it, life survives too, long after the suns that first gave it light have faded into memory. 15. The final refugees of the universe. The universe is far older than any civilization, older than any planet, older than any species that has ever lived. And yet, astonishingly, almost everything we see tonight is still living in the universe's youth. The stars above you, the galaxies stretching across space, the glowing nebulae where new suns are born, even the ancient light traveling through the cosmos, all of it belongs to an era that future astronomers, if any still exist, might someday remember as the Bright Age. Because one day, the universe will grow old. Not tomorrow, not in billions of years, not even in trillions, but over timescales so immense that ordinary human language begins to fail. And when that distant future arrives, a haunting question emerges. What will be left? When galaxies fade, when stars stop shining, when entire cosmic civilizations have become forgotten memories, which objects will survive the longest? Who will be the final refugees of the universe? Tonight we journey to the very edge of time itself, to an era where survival becomes the rarest achievement in existence. The first thing to understand is that the universe is surprisingly good at destroying things. Stars exhaust their fuel, planets collide, galaxies merge, black holes consume matter. Nothing appears permanent. Every structure we know exists within a larger process of change. Even our own sun, which feels so stable and eternal, is merely passing through one stage of its life. In about 5 billion years, it will swell into a red giant. The inner solar system will be transformed. Mercury will vanish. Venus will almost certainly disappear. Earth may be destroyed entirely or reduced to a scorched remnant. The familiar home of humanity will become part of history. Yet the universe will barely notice, because 5 billion years is only a brief moment compared to what lies ahead. Far beyond the death of stars like the sun, the cosmos enters an era ruled by endurance, and the first great survivors are the red dwarfs. These tiny stars are the champions of patience. While massive stars burn through their fuel in only millions of years, red dwarfs consume their hydrogen with extraordinary efficiency. Some may continue shining for trillions of years. Imagine a future where nearly every bright star has disappeared. The grand blue giants are gone. The yellow stars have faded. Even many white dwarfs have cooled. Yet scattered throughout the darkness remain countless dim red suns, small, quiet, persistent, like candles refusing to go out. If planets still orbit them, these systems may become the last islands of ordinary starlight in the cosmos, the final neighborhoods where warmth remains, the final places where life, if it survives, can still gather around a star. But eventually, even these patient stars reach their end. One by one, the lights go out. The age of stars concludes, and the universe enters something stranger, the era of stellar remnants. White dwarfs become increasingly important. These objects are the cooling cores of dead stars. Roughly the size of Earth, but containing the mass of a star, they slowly radiate away their stored heat. At first, they glow brightly, then more dimly still. Over unimaginable spans of time, they become darker and darker. Yet because the cooling process is so slow, white dwarfs remain among the universe's longest-lasting visible objects. A future observer might witness entire galaxies populated mostly by these fading stellar ghosts, ancient suns transformed into cosmic embers, still present long after their brightest days have passed. Nearby planets, if any survive, may continue orbiting these remnants. Worlds illuminated not by youthful starlight, but by the last fading warmth of stellar corpses. There is something deeply melancholy about that image. A civilization living beneath the glow of a dead sun. watching the universe grow darker around them, knowing that they exist in one of the final illuminated chapters of cosmic history. Yet white dwarfs are not the only survivors. Neutron stars endure as well. These extraordinary remnants are among the densest objects in existence, the collapsed cores of exploded stars, cities compressed into spheres only a few kilometers wide, matter packed so tightly that ordinary intuition becomes useless. Many neutron stars gradually cool. Others continue spinning for immense periods. Some maintain magnetic fields powerful enough to shape their surroundings long after their birth. In the far future, they become relics of ancient violence, memorials to stars that died billions or trillions of years earlier. And still, they survive. But eventually, even stellar remnants lose significance. The universe keeps aging. Time continues moving forward, and another class of refugees begins to dominate: black holes. At first, black holes seem like obvious winners. They consume matter. They grow larger. They survive events that destroy ordinary stars. Entire galaxies can disappear while black holes remain. In fact, many of the largest black holes may outlive almost everything else we know. As stars vanish and galaxies age, black holes increasingly become the dominant structures in the cosmos, the centers of dead galaxies, the anchors of forgotten systems, silent giants drifting through expanding darkness. For an incomprehensibly long time, it appears they might be eternal. Yet, even black holes are not truly immortal. One of the most astonishing discoveries in modern physics came from the work of Stephen Hawking. According to quantum theory, black holes slowly lose energy through a process now known as Hawking radiation. The effect is unimaginably weak for large black holes, so weak that no human will ever witness a giant black hole evaporating naturally. But given enough time, enough trillions upon trillions upon trillions of years, even black holes begin to fade. The universe eventually takes back what gravity once claimed forever. This realization changes everything, because suddenly there are no obvious immortals, not stars, not planets, not galaxies, not even black holes. Every refugee eventually faces the same truth: time wins. Yet before that final chapter arrives, there may still be extraordinary survivors. Rogue planets wandering intergalactic space, frozen white dwarfs, sometimes called black dwarfs, ancient neutron stars, black holes drifting through darkness, objects so old that they remember eras we would consider prehistoric. Imagine standing on one of those worlds. If standing were still possible, the night sky would be almost empty. No bright Milky Way, no nearby galaxies, no colorful nebulae, perhaps only occasional faint points of light separated by immense distances. The universe would feel lonely beyond comprehension, and yet it would still exist. The final refugees would continue their journey through time, long after the great civilizations, long after the great stars, long after the familiar universe had disappeared. There is a strange beauty in that persistence, because survival is one of the deepest themes in astronomy. Again and again, the cosmos creates structures that endure far longer than expected. Planets survive exploding stars. Moons survive planetary catastrophes. Galaxies survive collisions. Black holes survive the deaths of galaxies themselves. Every age leaves behind survivors. Every ending creates refugees. And perhaps that is why the far future feels less frightening than it first appears. The universe does not simply vanish. It changes, again and again and again. Each era handing the cosmos to a smaller group of survivors, until eventually only the most durable objects remain, the final refugees of existence itself. And as you drift deeper into the quiet of this night, imagine those distant survivors. Ancient white dwarfs cooling in darkness. Neutron stars spinning slowly through eternity. Black holes lingering where galaxies once lived. Silent travelers crossing a universe almost emptied of light. They are the last witnesses, the final keepers of cosmic memory, the closing pages of a story written across unimaginable spans of time. And somewhere among those fading remnants, lies a profound reminder. Nothing lasts forever, yet some things endure far longer than we can possibly imagine. Long enough to watch entire ages come and go. Long enough to witness the universe itself growing old. Long enough to become the final refugees at the end of time. 16. The long afterlife of cosmic worlds. One day, every star you have ever known will die. Not tomorrow, not in a million years, not even in a billion. But eventually, every sun in the universe will exhaust its fuel, shed its outer layers, collapse into a remnant, or disappear in an explosion. For most of human history, that realization has carried an unsettling implication. If stars die, then surely the worlds around them must die too. The story ends, the lights go out, the curtain falls. But tonight, after traveling through forgotten planets, rogue worlds, stellar graveyards, ancient survivors, and the deepest futures astronomy can imagine, we arrive at a surprising conclusion. The death of a star is often not the end of a world's story. Sometimes it is only the beginning of a much stranger chapter. Because stars may create worlds. But worlds often outlive the stars that created them, and their afterlives can last longer than anyone might expect. Imagine our own solar system, billions of years from now. The sun has already become a red giant. Its swollen atmosphere has transformed the inner planets. The oceans of Earth disappeared long ago. The familiar blue world became unrecognizable. Eventually, the sun shed its outer layers into space, creating a glowing planetary nebula before settling into a white dwarf. At first glance, it sounds like the end. The great engine of the solar system is gone. The source of warmth and light has vanished. Yet the planets that remain do not instantly disappear. Jupiter still circles the dead sun. Saturn still travels through the darkness. The distant icy worlds beyond Neptune continue their endless orbits. The architecture survives. The family remains. Only the parent star has changed, and that simple truth reveals something profound. Planetary systems are often far more durable than the stars at their centers. The universe is filled with worlds whose stories continue after the main source of light has faded away. Some orbit white dwarfs, some circle neutron stars, some wander through interstellar darkness, some survive explosions that should have destroyed everything nearby. Again and again, planets demonstrate a remarkable ability to endure. In a sense, stars write the opening chapters. Worlds write the epilogue. Consider the strange planets that orbit white dwarfs today. Astronomers have already discovered evidence that some planetary systems survive stellar death. Fragments of asteroids fall onto white dwarfs. Planetary debris forms disks around stellar remnants. Entire worlds may continue orbiting these ancient stellar corpses. The original star has died, yet the planetary system remains active. The story continues. There is something hauntingly beautiful about that image. A cold white dwarf shining faintly in the darkness. A surviving planet still making its lonely journey around a dead sun. Billions of years after the age of life and warmth ended. Billions of years after everything familiar disappeared. The orbit continues. The motion continues. The memory remains. And perhaps those are not even the longest-lived worlds. Because some planets may eventually become rogues. Gravity is never perfectly stable. Stars pass nearby, galaxies evolve, orbits change. Over immense spans of time, planets can be ejected from their systems entirely. What happens then? The world enters permanent night. No sunrise, no sunset. No parent star, no seasons. Only endless darkness stretching in every direction. At first, such a fate sounds tragic, but astronomy keeps teaching us not to underestimate survival. A rogue planet may retain internal heat for billions of years. Radioactive elements continue decaying. Deep interiors remain warm. Subsurface oceans may persist beneath thick shells of ice. If life ever emerged there, some of it might continue hidden below the frozen surface, protected from the hostile universe above. A rogue planet becomes something extraordinary, a world carrying its own refuge inside itself, a traveler surviving without any star at all. And as the universe ages, these solitary wanderers may become increasingly common. Long after ordinary planetary systems have changed beyond recognition, long after stellar neighborhoods have dissolved, the rogues keep drifting, silent refugees moving through cosmic darkness. Yet even they are only part of the story, because the future universe grows stranger with every passing age. Trillions of years from now, the bright era of stars begins fading. New stars become increasingly rare. Galaxies grow older. The cosmos slowly transitions from creation to preservation. The surviving worlds of that distant era may orbit tiny red dwarfs. These patient stars burn their fuel so slowly that some may survive for trillions of years. Imagine standing on a planet beneath such a star. The rest of the universe has aged beyond recognition. Many familiar stars are gone. Entire galaxies have changed. Yet your dim red sun still shines. The world remains habitable. Life continues. History stretches farther into the past than the human mind can truly comprehend. Those planets may become the final homes of ordinary starlight, the last warm shores in an increasingly dark universe. And when even the red dwarfs eventually fade, another chapter begins. Worlds orbiting white dwarfs, worlds orbiting neutron stars, worlds warmed by tidal heating, worlds heated by radioactive decay, worlds surviving through means that have little to do with sunlight. The further we travel into the future, the less important stars become. Survival shifts elsewhere, into gravity, into geology, into persistence, into adaptation. That idea feels almost biological. Life survives because it adapts. Perhaps worlds survive for the same reason. They change roles, they change environments, they change relationships with the universe around them, but they continue. And this brings us to one of the deepest lessons hidden inside planetary astronomy. A world is not simply a place, it is a history. Every crater records an impact. Every mountain remembers a collision. Every atmosphere tells a story. Every orbit preserves a memory. When a star dies, those memories do not immediately vanish. The planets remain as archives, silent witnesses carrying evidence of ancient ages. A rogue planet remembers the system it lost. A white dwarf planet remembers the star that once illuminated its skies. A frozen moon remembers oceans that may have existed billions of years earlier. The worlds survive as records of cosmic history. In that sense, planetary afterlives are not merely physical. They are historical. They preserve chapters of the universe that would otherwise be forgotten. Perhaps that is why these distant futures feel so moving. We often imagine astronomy as a science of beginnings, the birth of stars, the birth of planets, the birth of galaxies. Yet astronomy is equally a science of endurance, of survival, of what remains after the great transformations have passed. And the worlds we visited throughout this journey embody that idea perfectly. Ancient planets older than Earth. Rogue worlds wandering eternal night. Frozen oceans hidden beneath ice. Worlds orbiting dead stars. Planets surviving stellar catastrophes. The final refugees of aging galaxies. Each one tells the same story in a different way. The universe changes constantly, yet some things endure. Not forever. Nothing lasts forever, but far longer than intuition would suggest, far longer than civilizations, far longer than species, far longer than stars. And now, as our journey through these forgotten worlds draws to a close, perhaps the night sky feels a little different. Not empty, not silent, but filled with histories, filled with survivors, filled with worlds whose stories continue long after their suns have faded away. Somewhere out there, planets are still orbiting dead stars. Others drift alone between galaxies. Others wait beneath frozen shells, hiding ancient oceans in darkness. And all of them remind us of something extraordinary. The universe is not only a place of endings, it is also a place of afterlives. Thank you for joining me on this journey through the forgotten worlds of the cosmos. As the night grows deeper, let those lonely planets, dead suns, and distant reaches of space drift slowly through your thoughts. Let the rogue worlds fade into darkness. Let the ancient stars grow quiet. Let the last survivors of the universe continue their endless journeys far beyond sight. And as they do, allow your own mind to grow calm. Allow your breathing to slow. Allow the vastness of cosmic time to gently carry away the noise of the day. Sleep peacefully tonight, and until our next voyage among the stars, good night.